Welcome back to IMMEDICAL. Today I want to tell you a story, the big story of human papillomavirus and how it changes your life, my life, your parents' life, my kids' life, truly every person on this planet. We're diving deep into the latest HPV vaccination guidelines, but that's just the beginning. We're going to unpack the science, bust some myths and show you why this virus matters more than most people realize. It's going to be fascinating and maybe even life-changing. So let's dive in. Human papillomavirus, let's give it a proper introduction. Human because it infects humans. Wait, but are there any papillomaviruses that infect some other species? Well, yeah, it turns out that there are bovine papillomaviruses that infect cows. Oh, okay, good to know. Papilloma refers to the wart-like growth that you can see on the skin surfaces and mucosal membranes. And virus, well, because it's a virus. But what kind of virus? It's a DNA virus, and this is very important, as you'll see in a second. There are 200 types of HPV, and why this matters to us is because 70% of cervical cancers are caused by certain types of the HPV family. Transmission happens via direct skin-to-skin contact, primarily sexually transmitted, but also can be transmitted perinatally from mom to baby during the birthing process and can cause laryngeal papillomatosis in infants. I wonder who was smart enough to discover this little naughty fellow HPV. Enters Harald Zurhausen, a German virologist, a man who changed the world. HPV was first discovered in the early 1900s as the virus that causes warts, but the big breakthrough came decades later. In the 1970s and 1980s, Harald Zurhausen, a visionary German scientist, made a discovery that changed the world. He discovered that HPV-16 and HPV-18, these two certain types of the HPV family, cause cervical cancer. At that time, most scientists thought that the herpes virus was the one that's causing the cervical cancer. And as many pioneer scientists and geniuses, initially Harald Zurhausen faced big skepticism, but he persisted, and his groundbreaking research laid the foundation of the HPV vaccine, which has since gone on to prevent tens of thousands of cancers worldwide. And guess what? In 2008, he won the Nobel Prize in Physiology and Medicine for his discovery that human papillomavirus causes cervical cancer. Passed away in 2023, but his legacy lives on. A reminder that one determined mind can truly change the world. Let's honor trailblazers like him by staying curious, asking hard questions, and maybe even making a few discoveries of our own. Now let's dive deeper and really understand what's going on with this HPV. So wait, we said HPV was a DNA virus, and what does it matter? DNA, RNA, who cares really? Well, this little piece of information is a cornerstone of understanding everything about HPV and the HPV vaccine. DNA versus RNA literally explains why the HPV vaccine lasts for years and why you have to get the flu shot every year. It matters especially for how the virus replicates. DNA viruses like HPV and hepatitis B, for example, are genetically stable viruses. What makes them genetically stable is the way they behave. Normally, they enter the nucleus of the host cell and they use DNA polymerases. Some viruses hijack the host DNA polymerases like the HPV does and integrates itself into the DNA of the host cell. DNA polymerases, as you all remember, are high-fidelity enzymes. They proofread and they remove incorrect nucleotides. This leads to low mutation rates during replication. Unfortunate for us, makes them durable vaccine targets. That's why the HPV vaccine and the Hep B vaccine last for decades. No boosters needed, and we'll talk about this more in a second. On the other side, unfortunately, because they can integrate itself into the host DNA, they can cause latent chronic infections, like HPV is causing cervical cancers and hepatitis B can cause cirrhosis. RNA viruses like HIV, flu, and COVID mutate rapidly and cause acute infections. RNA viruses use their own RNA-dependent RNA polymerases, which, guess what they lack? They lack the proofreading capabilities of the DNA polymerases, which causes huge antigenic drift. That's why the flu shots need updating every year and HIV vaccine is so difficult to make. So we said that HPV has how many types? 200? Oh boy, that's quite a lot. So are they all bad? No, HPV rose up in two teams, Team Benign and Team Malignant. The malignant types are causing persistent, high-risk HPV infections that can lead to dysplasia and cancers. Types 16 and 18 specifically cause 70% of cervical cancers. 6 and 11 benign types can cause the anogenital warts called condyloma acuminata. The other benign types like 1 and 2 can cause the hand and plantar warts verruca vulgaris. These warts are benign and typically self-limited, but can be persistent or recalcitrant in some cases. Transmission within families and among close contacts is well documented, with studies showing that household members of individuals with warts frequently have the same HPV types detected on their skin, even in the absence of visible warts. Which basically means that if your mom or dad have it, you have it too. Congrats! There is of course the added benefit of auto-inoculation, which means that if you scratch on the wrong place and then you scratch a different part of your body, you can transfer the infection, let's say, from your hand to your foot. On top of that, the HPV DNA can be found on mats, on towels, on gym equipment, in nail salons equipment. So the risk of transmission is increased if you touch all these surfaces that contain the HPV DNA. So there's really no escape from it, unless you want to live in a bubble. So we said that HPV infects the skin and the mucosal membranes, but how does it do it? So if I shake someone's hand and they have a wart on it, or I go to a hotel and use their towels, or I step on a mat with my bare feet, or I go to the gym and use their equipment and there was HPV DNA on all these surfaces, are you saying that I'm just gonna get infected just by touching all the surfaces with the HPV DNA on them? Not really. HPV cannot infect intact skin. It needs a microabrasion in the epithelial surface to get inside, as in childbirth or skin-to-skin contact or sexual activity. These microabrasions open the door to the basal epithelial layer where HPV loves to hang out. So the virus enters the skin through this microabrasion, then enters the host cell via receptor-mediated endocytosis. The viral DNA is delivered to the nucleus of basal epithelial stem cells, where it persists and replicates. It does not burst the host cell. It does not enter the bloodstream. It just stays in the basal epithelial cells and does its thing. As the basal cells replicate and migrate upward toward the epithelial surface, HPV replicates and migrates with them, and HPV gets released when the infected epithelial cells just naturally sloughs off. Very elegantly, in fact, right? Why warts and lesions form in the superficial layers then? Because of the late viral proteins L1 and L2. They are only expressed in the superficial layers, the top of the epidermis. This is where the new virus particles assemble and prepare for release. And the result? You get hyperplasia and hyperkeratosis of the superficial layers. And that, my friends, is the visible warts that you can see. And because we mentioned late viral proteins, there must be an early viral proteins too, right? Unfortunately so. Some of the high-risk types of HPV like 16 and 11 have these special proteins, like protein E6, which suppresses the P53, the tumor suppressor gene, and E7 inhibits the retinoblastoma protein family that regulates cell cycle, which all leads down the line ultimately to dysplasia and cancer formation. And we'll talk more about the structure of the HPV in a second again. But why am I bothering telling you all that? It must be important, right? Well, yes, because of the fact that HPV does not burst the host cell and does not enter the bloodstream. The immune response to the infection is very slow and very minimal during natural infection with HPV, especially without vaccination. And that's why we vaccinate. So do I really need the HPV vaccine? I don't think so. I'm smart enough. I can protect myself, and even if I'm at risk, I don't think I'll get it. No, it's not gonna be me. Yes, I know that there are the malignant types that can cause cancer, and yes, that is scary, but still, I'm not convinced. I don't think I'll get it. I'm smart enough. I make good choices. I have raised wonderful children that can also make smart and good choices. Why do I need the vaccine then? If you're one of those people, I have bad news for you guys. Brace yourselves. HPV is the most common sexually transmitted infection in the world. It's not HIV, it's not herpes, it's not chlamydia or gonorrhea, it's HPV. Over 80% of sexually active individuals will get infected during their lifetime. The CDC estimates that only in US 42 million people are already infected with HPV. This is 42 million out of 336 million people in US. You do the math about the percentage here. And CDC also estimates that 13 million people get infected with HPV every year. So if you were wondering, what are your chances of getting exposed and infected with any type of HPV, and especially with the malignant types, which are the scary ones, during the first year of the beginning of sexual activity? The HPV is so widespread that your chances are 100%. So if there was a vaccine that can protect you with 99% effectiveness from cancers caused by the most malignant types of HPV, wouldn't you get it? That being said, if you get infected with the benign HPV types, they are usually asymptomatic and they clear on their own. So let's quickly recap. The vaccination with HPV vaccine has been a truly success story. It prevents you beautifully against the vaccine type HPV infections. It prevents you from genital warts. It protects you from high-grade cervical dysplasias and cancers. Even unvaccinated individuals benefit from the HPV vaccination through a herd immunity and decreasing the rates of transmission amongst communities. So HPV vaccination can really be a life-changing event for you or your children and prevents thousands of deaths per year, which is pretty awesome. But despite all this information, what if I still don't want to get vaccinated? Well, let's ask Africa. Africa has the highest incidence and mortality rate from cervical cancer in the world caused by HPV. Global epidemiological data suggests that the most affected region in Africa is the sub-Saharan Africa. And the numbers are so high because they don't have access to the HPV vaccines. They don't screen for cervical cancer. And of course, the high prevalence of HIV doesn't make things easy either. Well, I guess the cervical cancer is the most common cancer or something like that? Not even close. I wonder why. Cervical cancer is not in the top 3 cancers or not even in the top 10 cancers in the US, thanks to the vaccine that we have and the screening preventions that we run. The most common cancers in US are breast cancer, lung cancer, and prostate cancer. Cervical cancer accounts for roughly 13,000 cases per year, making it the 4th most common gynecological cancer, behind uterine, ovarian, and vulvar cancer. And again, why do you think that cervical cancer is not among the top 3 cancers in US? Well, because of the widespread HPV vaccination. It really works. It saves lives. So we said that it's important to vaccinate, ideally before the start of sexual activity. But how early is early? At what age should you vaccinate your child with the HPV vaccine? The ACIP recommends routine HPV vaccination for both boys and girls starting at the age of 11 to 12 years of age, with the option to start as early as 9. If you start the vaccine before the age of 15, you will need 2 shots, 6 to 12 months apart. If you miss that window 11-12 years of age, it's all good. You can still do the catch-up vaccination, it's called, until the age of 26. But if you start the vaccination after the age of 15 or you are immunocompromised at any age, then you just get 3 shots at 0 months, 2 months, and 6 months. So what if I'm in the maybe zone between 27 and 45 years of age? Can I still get the shot? Let's see what the guidelines say. ACOG and ACIP recommend that vaccination be considered on a case-by-case basis through shared clinical decision-making. Why? Because by this age, most individuals have already been exposed to HPV. As we said, you get exposed to HPV in the first years of sexual activity. On the other hand, the American Cancer Society is even stricter, and they recommend that if you're above the age of 27, don't even bother with the HPV vaccine. I'm sorry, it looks like you did miss the boat. So what if you're pregnant and you want to get the HPV vaccine? Is it recommended? Not really. Why? Because there is no data. We haven't given enough HPV vaccines in pregnant women to know if it's working or not. So how about in breastfeeding? Can I get the vaccine if I'm breastfeeding? Well, yes. HPV vaccines are safe and can be administered during lactation. And if you're wondering if any antibodies actually cross from the breast milk into your baby while you're breastfeeding, the answer is yes. After HPV vaccination, the most commonly produced antibodies are IgG, but there is some production of the secretory IgA antibodies that are found in breast milk. These IgA antibodies can protect the infant from oropharyngeal infections, which are not really that common in infants anyways. So I'm wondering, why do you really have to vaccinate your child as early as age 9? Well, there are two thoughts here. One is out of precaution if the child is at increased risk of, say, sexual abuse, or they have certain behavioral or medical risk factors, then it's recommended. Then it's best for the child to get vaccinated earlier than later. The official guidelines for now is to routine vaccinate children at the age of 11-12. But now most agencies tend to be more loose with the age target, and they think that if you start the vaccine at age 9, the immune response will be stronger, which leads to better protection in the years to come, and we'll talk about this in a second again. So why is it that young children between the age of 19 and 14 can generate such strong immune response? Well, because their immune system is naive. Imagine a blank slate, hyperactive and hyper eager to respond to any antigen it comes across with. Young children have very active lymphoid tissue that is eager to know and learn new antigens. Their B cells are more likely to undergo strong clonal expansion and produce a lot of IgG antibodies, which will ultimately produce memory B cells, which will protect you for decades to come from more HPV infections. And why do we give only 2 shots in young children and we have to give 3 shots in children more than 15 years of age? Well, because the 2 shots in young children are enough to produce this strong clonal maturation and strong immune response to protect you for years to come. Whereas once you hit 15 years of age, you need a third booster to help maintain those memory B cells in good levels. So how many HPV vaccines do we have? Well, we used to have 3, but now we have only 1. The Gardasil 9. No new vaccines have been developed, so no new updates for 2025. The current vaccine that we have is so successful that there is no need for development of new ones. Gardasil 9 can protect you from the most common 7 oncogenic HPV types, and it can also protect you against the HPV 1611 that, as you remember, caused the anogenital warts. Gardasil 9 is classified as a non-infectious recombinant subunit vaccine, which contains virus-like particles composed of the L1 major capsid protein from 9 HPV types. Wait, what? L1 major protein capsid? What is all that? Well, let's quickly talk about the HPV virus structure. HPV is a spherical virus. It has outer shell that's called capsid, which is made by L1 major capsid proteins, and this layer causes the immune response. Then under this layer there is another layer made of L2 minor capsid proteins, which assist in genome encapsulation and viral entry into the host cell. And inside the virus there is the circular double-stranded DNA. So Gardasil 9 contains virus-like particles composed of the L1 major capsid protein from 9 HPV types. These virus-like proteins are produced using recombinant DNA technology in yeast cells, Saccharomyces cerevisiae, and self-assembled to mimic the structure of native HPV, thus making them very immunogenic, but they do not contain any viral DNA, so they cannot cause infection in you, okay? Let's clear this out of the way. You getting an HPV vaccine does not mean that you're getting the infection. You're getting virus-like particles that can stimulate your immune system to produce autoantibodies to fight the HPV infection when you cross paths with it. Saccharomyces cerevisiae? Doesn't this sound strangely familiar? Isn't this found in those yeast packets we use to make bread at home? Yeah, exactly right. It's a species of yeast commonly known as baker's yeast or brewer's yeast because we use it to make bread, beer and wine, apart from being used in biotech and vaccine production. Interestingly enough, this specific type of fungus, apart from helping us produce vaccines that are saving lives and also are helping us make this fluffy bread and beer and wine, it can also trigger your immune system in a very different way. In certain conditions, which I'm pretty sure you all know about, our body can mistakenly produce antibodies against this beautiful fungus. And these antibodies are known as the anti-Saccharomyces cerevisiae antibodies, also known as ASCA. Ringing a bell yet? We use the ASCA antibodies to differentiate between Crohn's disease and ulcerative colitis. You have it in Crohn's disease, they're positive in Crohn's disease, and they're normally negative in ulcerative colitis. In ulcerative colitis, as you all know, P-ANCA is the one antibody that's positive most of the times. So let's recap. The HPV vaccine stimulates humoral immune response with mostly production of IgG antibodies. As you remember from the previous video, the IgG antibodies is the adult, the grown-up response. Ultimately, memory B cells are made, which contribute to long-term immunity, enabling rapid antibody production when the body gets reintroduced to the virus again. The antibodies produced after an HPV vaccination are much higher than the ones produced after a natural HPV infection. Do you remember why? Because the HPV mainly stays in the epithelial cells. It does not burst the whole cell. It does not go into the bloodstream. So the HPV virus really hides away from your immune cells that are circulating normally in your bloodstream. So your immune system cannot mount a proper immune response and antibody cell production and memory B cells from a natural infection. And the good thing about the HPV vaccine is that it lasts 10 to 12 years minimum, or maybe longer. No boosters are needed once you complete the full schedule of the vaccine. Boosters are only needed if you have not completed the full vaccination schedule. So how come this HPV vaccine can create such a long-lasting immunity? It all has to do with the viral-like particles that it contains. As we said, the viral-like particles mimic the virus structure perfectly. But again, they do not contain any DNA, so they cannot infect you. And because these viral-like particles look so much like HPV, your immune system aggressively reacts to them. It creates a beautiful immunity against it. Also, these viral-like particles trigger massive B cell activation, leading to high levels of IgG antibodies, long-lived plasma cells, memory B cells. This creates a beautiful plateau effect. Instead of antibodies being produced in massive amounts and then crash and burn, the antibody production peaks and stay elevated for years. The HPV does not mutate so much like the COVID and the flu, so there is not such a huge antigenic drift that we see with other viruses. Say you were proactive and you did vaccinate your child at the age of 9 years of age. Now fast forward 10 years in the future, because time does fly that fast. Your child is now 19 years old and of course still at risk for other HPV infections. Wouldn't you love to be able to test your child if they have enough antibodies in their system circulating around to protect from an eventual different HPV infection? That sounds like a great plan. Can it be done? The short answer is no. There is no such test that can test you for how many antibodies you have in your system. Why? Because first of all, there is no established antibody threshold. Like, we don't have a number that can tell you above this certain number, you're okay, you're protected, and below this number, you can get reinfected again. And most importantly, low or undetectable antibodies do not mean that you don't have the immunity to fight future HPV infection. Why? Because the antibodies that will protect you from future HPV infection are actually stored in your lymphoid tissue, in your spleen, in your stem cells. They don't just circulate around all the time. But if you get exposed to HPV infection, they'll get activated and they'll fight the infection. But what if you did miss that vaccine boat and you think you have been infected with HPV? Can you test yourself for HPV? Yes, we actually have two tests that have been developed for detection of HPV. One is called Cobas 4800 and the other one is called OnClarity. The Cobas 4800 HPV test and the BD OnClarity HPV assay are the most widely used and specific, as they individually identify HPV 16 and 18. Cobas 4800 HPV test is the most specific. It's FDA approved for primary cervical cancer screening. It is important to know that these tests do not detect the low-risk HPV types such as 6 and 11, nor do they distinguish between transient, persistent, or latent infection. Well, latent infection means that the HPV virus is basically sleeping in the basal cells without replicating itself. And active infection means that it's replicating itself, which can cause the cytological abnormalities that we see, dysplasias and the cancers. So what if you have already been exposed to HPV 16 and 18 and you have been infected with it? Can you get the vaccine regardless? Well, yes. If you are below the age of 26, it is recommended that you get the HPV vaccine because the HPV vaccine can protect you from the other malignant types of HPV that hopefully you have not come across with yet. Again, there is no need to test before you vaccinate. You just vaccinate and you go with it. Alright, so let's recap. The Gardasil 9 is a good vaccine. It's safe. It protects you from the 9 types of HPV types that it contains, almost with 99% effectiveness. But how about the rest of the 191 HPV types that are out there? Bottom line is that the vaccine does not protect you from all the HPV types that can cause cancer. It protects you only from those 7 oncogenic types and the 2 additional types that can cause the genital warts, and that's it. That's why screening for cervical cancer is so important, and that's going to be the topic of the upcoming videos. Also important to notice that the HPV vaccine will not cure you from any existent HPV types that you have already been infected with. The good news is that those 7 types of HPV that the Gardasil 9 contains are the cause for more than 90% of the genital cancers that we come across with. I really hope you learned something new and useful today. If you like our content, please subscribe to our channel for more videos on a daily basis. Also consider joining our membership. We have exclusive videos preparing you for the USMLE, the ABIM test, even for residency. Have fun studying, and I'll see you on the next one.